Lecture 21, Signal Flow Graphs, SFG. Consider the following two-port network. So here you have the S parameters. So here is port 1 and port 2. So a signal flow graph is a diagram that depicts certain relationship between signals in a linear network. It can also be used to solve for ratios of this signal. The key elements of a signal flow graph. First, the nodes will represent the system variable. So here you have two nodes. You have AK and BJ. Second, branches represent path for signal flow. So here, this will be the branch with the arrow pointing from AK to BJ. Number 3, a signal SJK. So here, this will be the signal. Travel along a branch between nodes AK and BJ, which is multiplied by the gain of that branch. So if you have this figure, the equation of the signal flow graph will be BJ is equal to SJK times AK. Number 4, the signals travel along branches only in the direction of the arrow. So this one is pointing only at one direction. So it cannot travel back. So this restriction exists so that a branch from AK to BJ denotes a proportional dependence of BJ on AK, but not the reverse. Finally, number 5, multiple branches into a node represent a summation or the addition of the signal. So for example, if you refer the previous this figure, so you have B1 is equal to S11A1 plus S12A2. So please refer figure 2. So B1 is equal to S11 times A1 plus S12 times A2. So that is for B1. How about B2? So B2 is equal to S21A1 plus S22A2. So for the SFG, that would be B2 is equal to S21 times A1 plus S22 plus times A2. Now, how to construct the SFG? Let's take a more careful look at the construction of the signal flow graph. So starting with the definition of the metric description of the two-port, you will have B is equal to S times A. So that will be the matrix. Or you will have B1, B2 because there are two ports is equal to S11, S12, S21, S22 times with A1, A2. So the first equation will be B1 is equal to S11 A1 times S11 A1 plus S12 A2. So using items 3 and 5 listed above, you will have, so how do you draw equation 3? So you will have B1 is equal to S11 A1 plus S12 A2. So that will be the SFG. Okay. So second equation, B2 is equal to S21 A1 plus S22 A2. So how to construct the SFG? That would be B2 is equal to S21 A1 plus S22 A2. So combining these two SFG, which is figure 3 and figure 4, that will give the overall SFG that has been shown earlier in figure 2, okay, which is the box, this one. But if we wish to construct just a single branch of this signal flow graph, We only need to match the transmitted port. So for example, if A2 is equal to 0, we see from 3 and figure 3 that B1 is equal to S11A1. So SFG will be B1 S11 times A1. While from 4 and figure 4, you will have B2 is equal to S21A1. So that would be the SFG is B2 is equal to S21A1. Now, you have to consider 4 rules that form the algebra of SFG. So the first one is the series rule. So series rule, given the two proportional relation, so you have V2 is equal to S21 V1. Then you have V3 is equal to S32 V2. And finally, you have V3 is equal to S32 S21 times with V1. How do you represent this relation with SFG? So the first one, V3 is equal to S32 V2. So it is represented here. V3 is equal to S32 V2. And then you have V2 is equal to S21 V1. That's why you have V2 is equal to S21 V1. So combining this signal flow graph, you will have V1 and V3 and then S21, S32. So that's why you will have the last equation over here. V3 is equal to S32, S21 times V1. So here V3 is equal to S21, S32 times V1. So in other words, two series paths are equivalent to a single path with a transmission factor equal to a product of the two original transmission factors. Product or the multiplication. So here you have the multiplication between S21 and S32. Now the second rule is the parallel rule. So consider the relation. So you have here V2 is equal to SAV1 plus SBV1, which is equal to SA plus SBV1. So in a signal flow graph, this is represented as, so you have V2 is equal to SAV1. So V2 is equal to SAV1 plus SBV1. So V2 is equal to SBV1. So notice this is a parallel network. So you can represent it, you can summarize it like this. So you have V2 is equal to SA plus SB times with V1. So in other words, two parallel paths are equivalent to a single path with a transmission factor equal to the sum or the addition of the original transmission coefficient. Next, we have the self-loop rule. So please consider the relation. So you have V2 is equal to S21 V1 plus S22 V2. And you also have V3 is equal to S32 V2. We want to eliminate V2 from these two equations. Okay, so how do you do that? So here you have V2 times 1 minus S22 will be equal to S21 V1. Okay, this is taken from this equation. You want to get rid of V2. Okay, so that's why you will have this equation over here. So finally, V2 is equal to S21 over 1 minus S22 V1. So plug in this equation into equation 8, which is this one, V3. Okay, instead of using V2 here, you use this equation. So V3 would be equal to S32 S21 over 1 minus S22 V1. So how do you represent this with SFG? So the first equation is quite complicated. Okay, like this one. So you have V2 is equal to S21 V1 plus S22 V2. So it is represented here. Yeah? Okay. So V2 is equal to S21 V1. Okay. S21 V1 plus S22 V2 plus S22 V2. Okay. And then you have V3 is equal to S32 V2. So it is represented here. So V3 is equal to S32 V2. How do you simplify this? So you simplify it by using this equation. So you still remain with V3 is equal to S32 V2. Okay, no problem with that. So how do you simplify this loop? So V2 would be S21 over 1 minus S22 V1. So that is represented here. So finally, you will summarize it with this equation where you get V3 is equal to S32 S21 over 1 minus S22, which is represented here, times with V1. Finally, the splitting rule. So consider the relationship. Here you have three equations. So the first one, V4 is equal to S42 V2. So V4 is S42 V2. V2 is equal to S21 V1. V2 is equal to S21 V1. And V3 is equal to S32 V2. V3 is equal to S32 V2. So from equation 10 and 11, we find that V4 is equal to S42 S21 V1. So if we use the series rule in reverse, we can define V4 is equal to S42 V2 prime and V2 prime is equal to S21 V1. So how do you represent this? So this is taken from the previous figure. Okay. So you simplify it this way. So you have V4 is equal to S42 V2 prime and V2 prime is S21 V1. Okay. So in other words, a node can be split such that the product of transmission factors from input to output is unchanged.